Assuming you put Betelgeuse where the Sun is, it would expand to the orbit of Jupiter, becoming a massive unstable beast on the verge of detonation. Betelgeuse is one of the most noticeable stars in the universe, emitting more energy than 1 billion suns. Known as a red giant star, it is so large that if placed in the Sun's position, it would reach the orbit of Jupiter, an immense erratic object ready to explode. When we think of stars, we typically imagine small twinkling lights in the night sky, which is how we see them from Earth. However, stars are far more complex, and one of the most remarkable of them, Betelgeuse, is much larger and more fascinating than our own Sun. Betelgeuse has baffled astronomers for years, and recent developments, especially from the James Webb Space Telescope, JWST, have revealed even more troubling information. The star's unpredictable behavior has left scientists increasingly concerned. In this article, we explore the magnificent new findings about Betelgeuse, its impending destruction, and the impact this will have on the universe and life on Earth, as explained by physicist Michio Kaku. A colossal star on the brink of destruction. Betelgeuse is a massive wonder, a colossal star that has intrigued astronomers for centuries. The Greek astronomer Antonius first discovered it. It is so enormous that it can be seen from Earth, especially during the winter months. If you're interested in cosmology, you've probably heard of or seen this star. It marks the upper left shoulder of the Orion constellation. Betelgeuse is an aging star and perhaps one of the most marvelous stars in the night sky. However, its brilliance is far from stable. It fluctuates in brightness, which is one of the star's defining characteristics, and this change is something we must examine further. Most of the stars we see are located far away from Earth, with the closest star being about 4.2 light-years away. To understand light-years, imagine traveling at the speed of light for an entire year. Light moves at a speed of 186,000 miles per second, and in a year it covers trillions of miles. So when we say a star is 4.2 light-years away, we're talking about a distance of billions of miles from Earth. Betelgeuse is much farther, located around 600 light-years away. Even at the speed of light, it would take 600 years to reach it, a time frame far beyond our current technological capabilities. Despite this immense distance, Betelgeuse shines incredibly brightly in our sky. The immense size and unstable nature of Betelgeuse. Betelgeuse's immense size is the reason it remains so visible despite its distance. It is about 10 to 20 times more massive than the Sun, and its radius is many times larger. However, when viewed through telescopes, it appears as a disk rather than a small point of light, unlike other stars. This is likely due to the reactions taking place in its outer layers. As for its mass, Betelgeuse is estimated to weigh between 12 and 19 solar masses. A solar mass is the standard unit used to measure the mass of stars, with one solar mass being roughly 210 superscript 3 kg. Since Betelgeuse lacks any companion stars or planetary bodies orbiting it, scientists can't determine its exact mass. However, it is clear that it is far heavier than our Sun. A flickering giant. The star's variability and magnetic spots. Betelgeuse's brilliance is another key characteristic. Its luminosity ranges from magnitude 0 to 1.6, with magnitude 0 being 2.5 times brighter than a magnitude 1 star. At its brightest, Betelgeuse can be many times more luminous than our Sun. This variability in brightness is due to the star's throbs or pulsations, where Betelgeuse expands and contracts. When it expands, it gets brighter. When it contracts, it dims. These throbs can last anywhere from 10 to 100 days, contributing to the star's dynamic appearance in the night sky. A unique feature of Betelgeuse is that its surface is covered in dark magnetic spots. These spots are regions where the magnetic field is stronger than in surrounding areas. They interfere with the flow of hot gas to the star's outer surface, making those areas cooler. This phenomenon helps explain why Betelgeuse is cooler than our Sun despite its massive size and brilliance. The spots on Betelgeuse are much larger and more numerous than those on the Sun. In fact, some spots can be twice the size of Earth. Betelgeuse also has a magnetic field many times stronger than the Sun's, causing the gases in its outer layers to swirl and bend. The star has a surface temperature of about 3,500 K, which contributes to its weak red color. The evolution of a dying star. Betelgeuse wasn't always a red star. Around 100,000 years ago, it was yellowish, much like our Sun. Over time, it began changing color, shifting from orange to red. Around 10,000 years ago, it transitioned into the red giant we see today. Despite its enormous size, Betelgeuse is not the largest star we know of. However, its fluctuating brilliance and dynamic nature result from its ongoing throbs, which cause it to expand and contract, altering its brightness. Like other red giants, Betelgeuse is nearing the end of its life. It has exhausted the hydrogen fuel in its core and is now fusing heavier elements such as helium and carbon. This fusion process produces energy, causing the star to expand. When Betelgeuse runs out of fuel, it will undergo an extreme fusion process, producing even heavier elements like carbon and oxygen. This will cause the star to expand even further, making it one of the largest stars in the night sky. Eventually, it will explode in a massive supernova, marking the end of its life. The force of this explosion will be so powerful that it could dominate an entire star system and send shockwaves through space. What happens next? The implications of Betelgeuse's supernova. While this supernova is not imminent, scientists are closely monitoring Betelgeuse's behavior. Some believe it could go supernova within the next 100,000 years, a short period in cosmic terms, but still too far off to predict precisely. Thanks to the James Webb Space Telescope, JWST, astronomers can now study Betelgeuse's outer layers and magnetic fields in unprecedented detail. These findings confirm the star's ongoing changes, irregular brightness, and potential instability. When Betelgeuse finally explodes, it will release heavy elements such as iron and nickel, which are crucial for the formation of planets and celestial bodies. The shock wave from its supernova could even trigger the birth of new stars in surrounding regions. While we may not be around to witness Betelgeuse's final moments, its legacy will live on, both in the elements it creates and the knowledge it provides to future generations of astronomers. By studying stars like Betelgeuse, we continue to unravel the mysteries of the universe, gaining a deeper understanding of stellar evolution and the cosmic forces that shape our existence. What happens after Betelgeuse explodes? Once Betelgeuse undergoes a supernova, the star's core will collapse under the force of gravity. This collapse could result in one of two possible outcomes: neutron star formation. If the remaining core mass is between 1.4 and 3 times the mass of the Sun, the gravitational pressure will crush the atoms, forming a dense neutron star. These stars are incredibly compact, with a teaspoon of neutron star material weighing billions of tons. Black hole formation. If the core is more than 3 solar masses, the collapse will continue indefinitely, forming a black hole, a region of space with gravity so strong that nothing, not even light, can escape it. Will Betelgeuse's supernova affect Earth? Because Betelgeuse is about 600 light-years away, its supernova is not expected to harm Earth directly. However, it will produce an enormous burst of radiation, including X-rays and gamma rays. Fortunately, this radiation is not expected to be strong enough to affect Earth's atmosphere or biological life. Some scientists estimate that a dangerous supernova would need to be within 50 light-years to pose a real threat to Earth. Instead, the explosion will offer astronomers an unprecedented opportunity to study a nearby supernova in real time. The James Webb Space Telescope, JWST, and other observatories will provide crucial data on the physics of star death, helping us understand the life cycles of massive stars. The bigger picture. Betelgeuse and cosmic evolution. The death of Betelgeuse is not just an isolated event. It is part of the grand cycle of stellar evolution. The elements created in its explosion will be scattered across space, enriching the interstellar medium. These elements will later be incorporated into new stars, planets, and even living organisms. In fact, the iron in our blood and the calcium in our bones were originally forged in ancient supernovae. While Betelgeuse's fate is sealed, the exact timing of its explosion remains uncertain. It could happen tomorrow or 100,000 years from now, an instant in cosmic terms, but a long time for human civilization. Final thoughts. Betelgeuse continues to captivate astronomers and space enthusiasts alike. Its impending supernova will be one of the most exciting events in modern astronomy, offering an extraordinary glimpse into the violent yet beautiful nature of the universe. As we await its eventual fate, ongoing studies of the star help refine our understanding of stellar life cycles, the formation of elements, and the future of our own Sun.